So thank you for joining this session on DDD with Java and Spring. I hope you had a great sandwich, refreshed yourselves, regained some power for the next, 3 hours, 2 hours, 45 roundabout. We're going to do a break in the middle. My name is Oliver Drotbohm. I have worked in the Spring engineering team for over 15 years now. It's my 16th year. I've done quite a bit of data for a long time, so if you've ever used any of the Spring data libraries, that's stuff that the team that I built around a decade ago and I have kind of worked on. I've recently it's been pre-COVID basically, when I moved on into a bit of more architecture-related work. Even the data stuff my work in that was mostly architecture-related, where it was about a pattern that we're going to talk about today as well, implementing repositories for the Java space, or the Spring space at least. So I've kind of let people that in the meantime know more about that stuff than I do, and then moved on into even more architecture-related stuff, talking to customers what kind of applications and architecture ideas they want to implement in their applications. And then in the Spring team, we kind of try to not get into the way of these ideas, or even better, support those, right? And for a very long time, you've got those, or that kind of support served in the form of the Spring Cloud projects, where it was about mostly microservices and the challenges that arise from that architectural style. And there's been a new project, relatively new. I think the first commit is from 2017, called Spring Modulith, that we're going to see in the second half of the project, which is the thing that I'm spending most of my time on, and a bit of time at conferences talking about this stuff. Right. Enough about me. What's going on, or what we're going to talk about today. We're going to have this 10-15 minute break in between. So we have two halves actually, and we're going to spend the first part on domain-driven design mostly, and the tactical building blocks of domain-driven design. So we talk about value objects, entities, aggregates, repositories. And our primary focus is going to be how we actually put those into code. I'm not going to do a DDD introduction and basically tell you what the characteristics of entities are versus value objects and whatnot. I hope that you have at least a vague idea of that. To be completely honest, it's not to follow this talk, it's not necessary to be a DDD expert of any kind or whatsoever. It's more about this kind of, you're going to get that in a minute, about the idea of thinking in higher level abstractions and how we actually get them into code. Whether that's a value object or something that's specific to your project doesn't necessarily matter, right? I just quote unquote chose that pattern language because it's one that many developers are at least vaguely familiar with, right? The second part of the first part is going to introduce jMolecules to you, and we're going to see what that is in the first place, what that can do, and how that basically changes the way you work with DDD in your code bases. The second part, so we start small, right, with the building blocks, as the title says here. The second part is going to be all about modularity. So we basically zoom out a bit and talk about, okay, we have different parts in our application. How do we actually express those parts in code? Whether that's you elevate those parts to become bounded contexts, or whether it's just modules, right? That doesn't matter so much. We're kind of okay, we want to establish individual parts, and we use the term application module for that, how we establish those, and what that actually, just the fact of establishing those modules in your code base does to the way you can actually work with the code base, right? And basically the fourth quarter is going to be about how do these modules then interact in a typical Java/Spring application, and what does that mean for the terms of consistency, like transactions and whatnot. The session type is called deep dive here, which means that we're going to, of course, take a look at more detailed things. That said, the entire content you're going to see here is actually derived from a one-day workshop one-day one, or sometimes even doing as a 2-day workshop. So there's quite a bit of stuff that I have to had to cut out to fit it into the 3 hours. That said, there are luckily there are a couple of other talks that I am allowed to give here on Thursday primarily. So there's going to be more on Spring Modulith if you're interested in that on Thursday in around noon. And a lot of the reasoning behind why do we get to this module abstraction as we got to will be discussed in the second talk, the domain-driven Y-hexagonal and onion architecture are answers to the wrong question. Slightly provocative. This is going to be a much more nuanced discussion. It's just that's the way you write talk headlines these days, right? And of course, not to forget, if you want to talk to anyone on the Spring team, there's a couple of us, not all of course, but quite a few of us are here to meet you and chat on Thursday, late afternoon, early evening. So there's a couple of course, if I talk about applying domain-driven design to your Java and Spring projects, then there's the question about it is very related to writing source code and laying out source code, how to design that. So we're going to look at a couple of examples. There is, as I mentioned, because of the fact that I have to condense a couple of things, I needed to plug unfortunately, code from different code bases. But the primary thing we're going to look at is this tactical DDD workshop thing, and there's a bit I don't know right now from the top of my head about what parts we are going to look at the arc evident thing. But I think that's mostly for the second half, right? All right. That with the logistics aside, that's kind of the thing I want to start with, right? So who agrees with that? So why is that? Half of you didn't show your hands. What are you guys thinking then? So for those who agree, why is it? Because I just put this up on the slide. So what's kind of what's the reason for that? The reason for that is that almost all the cost that is caused by a piece of software is not happening here, and unfortunately, many teams or many if you look at the way that technology gets advertised, right? It's about that. Here's a new framework that I can build something, a REST web service in 5 minutes. Who is lucky enough to earn their money with REST web services they've thrown together in 5 minutes? A couple of you, lucky you, right? In case you're hiring? No, just kidding. So most of us spend their work time with that kind of work, right? All the work that's taking an existing code base to a new state. Basically, we add a new feature. So there's a great talk by Kent Beck that resonated with me quite a bit from some DDD Europe conference recently. He said there's only 2 kinds of activities that you do to your software. One is to increase the value or to cut the cost. There's nothing else makes any sense to do to your software, right? These 2 activities. So ideally we want to optimize for that for those activities taking place in that green area, right? And how to achieve that is a topic that Carola Lienthal has covered in her. It's actually I think a slightly polished version of her dissertation in a book called Sustainable Software Architecture, where she goes into the details of what makes software understandable, right? And understandable and maintainable ultimately. And there's a couple of concepts taken from cognitive psychology, like chunking, which is kind of we're not. The best example I think for chunking is you're not reading, when you're reading prose, you're not reading letter by letter, but you kind of read the words by words, right? You read them as a whole, as a chunk, basically. Hierarchization means we organize things in hierarchies, in relations to each other, and ideally those hierarchies are non-cyclic, right? So if there's the hierarchy is a directed acyclic graph, it's easier to reason about because we can just take a node and then basically find out about all the paths that are that we need to understand first before understanding that one. And the third one, and it's actually the most important one, I think, is that in the book she gives quote-unquote evidence that the more code of a project is assignable to a certain pattern language, the easier it is to understand and to maintain, right? So they have a maintainability study in there, or a couple of maintainability studies, not only in Java, also in other languages. And there's this common pattern about like, okay, whenever we find ourselves being able to assign more abstract concepts to elements of our code base, the easier it is to understand the code base, that is, right? And one of those pattern languages, coincidentally, is defined, not holistically defined, but it's kind of a certain set of patterns is laid out in Eric Evans' domain-driven design book, which is the tactical building blocks, mostly consisting of, that's a graphic from the book, and the ones that we're going to be interested in are these today, right? So there are certain patterns. What does that mean? So there's literally, he introduces new concepts. You can debate about the fact whether they were actually new, but because like database theory talks about an entity relationship diagram, right? So the term entity is not something that he invented, but he basically defined a concept name and then associates rules with that, right? Value objects need to be immutable, they need to be shareable, and they don't have identity except their properties, right? 20 euros are 20 euros, right? They're exchangeable. If you add something to, if you add 10 euros to the 20 euros, you're not changing the value of the 20, but you get a new 30 kind of thing, right? Entities have identity. Aggregates are basically like consistency boundaries around a set of entities. Repositories are factories for aggregates, right? Basically reconstituting them from a database, for example. And then there's services for all kinds of code that involves more than one aggregate or what have you, right? So that's kind of the thing that Eric does in his tactical, in the tactical part of the DDD book. There's of course this entire other world of the strategic design, but that's mostly revolving around the way that different pieces of software interact with each other, what kind of roles they play in relation to each other, and what have you. And these are the things that you usually have to deal with when you build like a piece of software individually, right? So what are the entities? What are the events in my system? Where do I put some business logic and what have you? The question of how to translate these kinds of concepts into code is the topic of chapter 10 of this book. Who has heard of George Fairbank's Just Enough Software Architecture before? It's, I think, one of the most underrated software architecture books out there. I discovered it through Simon Brown in his, Software Architecture for Developers, like books and talks. And the chapter 10 is titled, I think, Bridging the Model Code Gap. So we have this logical model of our system, and then we have this kind of piece of code or pieces of code, files, classes, methods, what have you. And George lays out that we somehow have to connect the two, because we kind of, whenever we touch a piece of software, we actually have to bridge that gap every time we do that. And the easier it is to do that, the easier to maintain is our software, right? And he comes up with a term that I think that's the kind of cornerstone of that chapter. It's called architecturally evident code. What does that even mean, right? And he defines it as we're leaving traces of our design decisions and design ideas in the code base. The same way that we do not just name a class that's got to, I don't know, abstract a customer or something, we don't name that something different. We give it the name of the domain concept, right? So that's kind of it's kind of an activity of writing architecturally evident code, right? It's putting the domain into our code base. And George, in turn, references a paper by Adam Eden and Rick Kuzman that categorizes architectural approaches into extensional and intentional elements. Welcome to the university lecture of software architecture here. But it sounds more complicated than it actually is. Extensional elements means we describe things by enumerating them. My system consists of an order subsystem, an inventory subsystem, invoicing, and shipment, right? And the core characteristic of extensional architecture elements are that they are relatively easy to translate into some abstractions in our code base, right? I'm not saying that it's easy to decide whether we should build our different logical units that we have as modular monolith or as microservices, because there's a lot of like architectural requirements to be considered, but there is a way to translate one or the other, right? When we decide we want to build this as modular monolith, maybe we could have different build modules for each of those, or we could use packages. If we go down the microservices route, then there's probably some deployable unit of code that will be representing the invoicing or the shipment part or what have you, right? So there is a way of assigning the logical element to some kind of element of the physical world, if you want to talk about physical things in software in the first place. The same applies to the domain language, right? So we can. That's what I mentioned with the customer class a few minutes ago. You have this terminology, and that's actually what a lot of what Eric discusses in the ubiquitous language aspect of domain-driven design. You have this terminology. You want to talk to business experts. You want to talk to these to people that work in the domain, and it's important to use those terms in your code base as well, right? So that's why we name classes after these concepts. We have a customer. We have, I don't know, first name, last name, properties. We have this language even translated into our database columns, ideally, right? So that's kind of another thing. The domain language is something, for one, extensional element, and for the other, or as a consequence of that, easily, quote unquote, representable in our actual code bases. So if there's the easy part, then there's probably a complicated part as well, which is then the intentional elements. Meaning we're not defining by enumerating things, but we define by defining a concept and attaching rules to that concept, so that those concepts then are like ubiquitously applied to our code base. And pattern languages are a means, or are such an intentional element of architecture and design, right? I'd probably like assign or think of the DDD pattern language as a design thing rather, and things like hexagonal architecture, onion architecture, layered architecture, CQRS, that they are more on the architectural side of things, right? And with these like concepts and rules kind of tuples, like how do we actually represent those in code bases, right? We could go ahead and say, okay, we want to make all our entities visible in our code base, so everything that is an entity gets the naming suffix entity, which then basically results in customer entity, or I don't know, customer repository, right? You've probably seen that one somewhere. But that kind of is at odds to some degree with our intent from like the domain language to keep that as pure as possible, right? We don't necessarily want to like augment our terminology with these technical artifacts, right? It gets even more complicated with these higher level abstractions like layers and rings, because like how do you define a layer in a code base? Packages, anyone? Don't. I'm going to come back to that later, right? So what are just to make this for the more visually driven people of yours, like what are the individual elements that kind of take part in this exercise of applying concepts to code? So for one, we have our user code, basically the code that we write. There's architectural concepts and rules. So we could go ahead and say we stay with the domain-driven design, tactical building blocks. Let's say we build our tiny domain model. That's not the domain model here. I usually rant about people that just show data and then call that domain model. But we have concepts here that relate to each other, right? And we apply domain-driven design terminology to that model. So we have an order that's located in some kind of orders space, module, what have you, and the order consists of a set of line items, like one or one to many. The order, quote unquote, belongs to a customer, so someone has actually placed that order, but that customer concept lives in some other place separate from the order. So there's a lot of information in here, and we already logically applied some of the tactical building blocks to that class model here, right? So there's an aggregate, it's like the UML stereotypes here, and the customer is an aggregate, order is an aggregate, entity is an aggregate, right? So we could put this on a whiteboard, like in our team. So okay, we design it that way, and basically go ahead and just place it on a whiteboard for now. So we have our code, or we could think about it. Okay, here we put this in code, right? Create classes. Probably even some code generation could be going on here if you want it. But there's a direct translation from this thing into the code-based world right now, except for the UML stereotypes, right? We have the concepts here, but how do we get the concepts into the code base is one question. And the other question is that while the concepts have these rules attached to them, which allows us to, quote unquote, verify the model in the first place, right? Is this a proper design here? And does anyone see a problem with that design? It's intentionally wrong. It's usually no hand. Yeah, no hand. It's probably, but there's one hand. The aggregate that doesn't have any entities like customer, that's not a problem per se. An aggregate is an entity, and it could have like access to multiple ones, but there is like one rule that actually Vaughan Vernon spelled out very explicitly in his implementing domain-driven design. Aggregates only refer to other aggregates via their identifiers, right? So modeling the to-customer relationship as a full entity or full aggregate relationship is wrong here. We shouldn't do that. For whatever reasons, I think we're going to come to some of those aspects into later on. And first off, it's not particularly relevant why that is, right? My point is there are these concepts and there are rules attached, and we can actually verify that this thing is wrong, quote unquote. It's not terribly wrong. It's just like we would basically go ahead and instead model this as identifier reference, and then whenever we need access to the customer, we could basically resolve that through the corresponding repository. That would be it, right? The point is, we can, like, let's say we have a team of people that kind of are familiar with DDD. We can whiteboard this thing, and we can then somebody would probably point out, oh, there's this problem, we shouldn't do this way. So we probably change the model and also change the code accordingly. But what if we actually could go ahead and basically find those problems in our code base, right? So if the code actually gave us the same feedback. And we can actually do that. There's like two more elements involved in that entire exercise, which is some kind of technology, because it's not that kind of that this is a very new thing really. It's just that for one, there are tools that you can use to imply or apply these logical validations, these rule sets onto your code base. And the other thing is that frameworks are usually involved in relation to these tools. I can give you an example in a second, but let's say we were able, let's say kind of us at the very top, there's your code, and there's like this kind of tooling that you're using in terms of frameworks or separate tools. Let's say we had this kind of suspiciously looking guy there representing, okay, some means to express our concepts in our code base. We could then our exercise would be, okay, to assign here, this class is an aggregate root, this class is a value object. And then the tooling could actually prepare the rule checks to relate to exactly those expressions, right? We would not have to go ahead, and that's what I see teams usually doing, which is fine in the first place, using tools like RQnit, JQ Assistant, right? To have a basically write code that says all classes that are annotated with JPA at entity are entities, and they must not depend on, I don't know, repositories or what have you, right? You can define these rules There are tools for that. That's all great. It's just that whenever you start a new project, you're not going to spend like the first 2 days, before we start implementing any feature, let's define all these rules in the first place, right? Even more so because these rules are not something you invent, really. They are kind of like established already, right? But if there was a way to find entities in the code base, these rules or these rule checks could be prepared on the tool side. So let's say, what if there was something that we basically use, let's say we use ArcUnit, and there was like an easy way to say, here are some classes, verify them for DDD validity, for example, right? The other thing that plays into this are frameworks, as I said, right? So, for example, if you're like familiar with the Spring Data projects, you have repositories, and it's usually they have this generics declaration. It's a repository for customer or something, and while it's not actually the way that an aggregate is defined, but identifying aggregates in a code base or a kind of approximation of what are the aggregates of my project could be to find all the repositories and then check the generics declaration, because by definition, only aggregates are maintained or handled through repositories. Entities are not, right? Like a line item within an order doesn't have a repository, but the order has one defined, right? So you can kind of invert that relationship to be as close as possible. That doesn't really guard you against like invalid definitions of such, but oftentimes these like rule definitions, how do I find an aggregate in my code base, have some reference to some technology like Spring Data or what have you, which is unfortunate because it's not Spring Data's business to define these kind of things, right? The other thing would be to, if we have certain frameworks, I don't know, let's say database persistence mappings or whatnot, if they can operate on a higher level of abstraction, we can prepare those, or prepare your code to work with these technologies in a slightly better way, right? So let's say for an aggregate, there's a lot more assumptions you can make in terms of the persistence mapping. We're going to see that in a bit, right? So the tools and frameworks can actually then refer to that information, to that higher level information in the code base. And that suspiciously looking guy is not a guy, actually. Lucky about that. But a project called jMolecules. It's kind of a collaboration between a couple of folks that work in this area. There's like Henning Schwendner from WPS in Hamburg, Stefan Pirnbaum from the JQ Assistant team. JQ Assistant is a Java quality assistant, also like a code quality tool. And we've been exchanging at a couple of conferences, and jMolecules is basically the Java variant of some higher level thing called xMolecules, which aims to provide these higher level abstractions for different programming languages. So there's a PHP molecules, a N molecules for .NET, which I am both not involved with, not because I don't like the languages, but I just work in Java all the time. So that's what you're going to see here. So the idea is that we have libraries that provide you programming language specific means of expressing these design and architectural elements in your code base. There's libraries for, there's artifacts. This is basically the artifact tree here. There's artifacts for domain-driven design for anything related to events. So you can basically mark a class as domain event or event listeners, which are methods. And then it's not a class, it's a method then. And that's the entire world of architecture things where we currently have support for Onion, hexagonal layered architecture, and CQRS systems. And Onion is available in like 2 different flavors because there's been like discussion amongst the team, like what would be the better approach here. So what does that mean? So we take these libraries. They are thin libraries, basically a collection of annotations and interfaces. So no implementation code whatsoever, except tiny exceptions. But we apply those to our code base, and then the question is like, what do we get from that, right? So I'd argue it's more expressive code, verification, we can extract documentation, and we can even eliminate some boilerplate code here. And I would like to basically show you the first two parts in a demo right now. Right, so where's my cursor? Here it is. Right, so does that work? I can zoom in one more. So what you have here in the tactical DDD workshop verification thing is just it's a start for a domain model. It's basically just like certain concepts from the domain, and we're building up a relationship, right? So here we have an address. That's a classical value object. There's a zip code involved here that basically verifying it's about German zip codes. So we have 5-digit numerical things here. And it's just like a Java record to represent that, right? For value object discussion, that we can have that in the break, for example. So then there's like the customer. It's basically the example that I had on the slide before. That's supposed to be an aggregate root. And the order is an aggregate root as well. And there is, what we're also making use of in here is some integration that's part of a kind of giant basket of integrations into different technologies of that jMolecules thing, right? So the jMolecules is basically a two-part thing. One is the specification and the types that you're going to see used in a second, and the other one is everything that's integrating with either quality tools, with Jackson, with Spring, with JPA. We're going to see that in a bit. We're making use of ArcUnit here. So there is this, the way you work with ArcUnit is basically you tell it to analyze a certain part of your code base, right? Packages of this very class. So basically, this package is our scope. So all the types in here. I have an assumption in here that just to make the code work for now. And then there is a class called jMolecules DDD rules that has like all the rules that we currently support for implemented as public static methods, so that you can refer to them individually. So you basically select which rules to apply, or you just go ahead and take the all rule. Right? There's like everything that's. Oh wait, I should not have zoomed in here. So where was the method all? There we go. Right. So that's kind of the composite architecture rule here. We are making use of individual ones in the in this test case here, and this is the one that I'm going to look after, right? So we have, if you remember the example before, we have our order here, and that order has exactly the customer relationship, so the relationship to the full aggregate on the other side, which we deemed invalid, right? And I can run the test case now, and it basically just skips over the test because the order is not an aggregate root yet. So how do we turn it into one? That's kind of where jMolecules come in. There's like two ways or two flavors of jMolecules DDD and abstractions. One is an annotation-based variant. That would be that. Right? So you can annotate your class with aggregate root. Or the thing I like slightly better is, and we can talk about the differences in a second, is basically an interface here. Right, so that's an aggregate root, and if we turn the customer into an aggregate root as well, I get to the oh, let me just do that to the end and finish my thought here. So we go here, and then we run the test, and we basically get that architecture rule to fail. So fields that are not static and synthetic, yada yada yada. Implement was violated one time. Here's the error message, right? Field order customer refers to an aggregate root. Rather use an identifier reference or association. So what we have to change this into now is basically to make that work is we have to go customer ID and then do get identifier here, right? So that thing would basically be satisfied, and I can run the test again, and it would be green again. What you also already saw is that customer was kind of seeing those, like, it looks like a compiler error here, right? See what's going up here.
You only changed the field name, not in the constructor.
No, I'm deliberately going back to the thing that was before, right? You don't even have to run the test to actually get the error message. Right? It says invalid aggregate root reference. How's that? Like, how does our customer, not our customer, but the compiler apparently knows about domain-driven design? Of course it doesn't, right? So what's at play here is a APT. Why did it work before? It's kind of weird. It shouldn't have, right? But that's kind of what I would. Why doesn't it? Shouldn't actually. Let me go ahead. Maybe I didn't refresh the. No. I have to rebuild it because that's kind of like this Maven thing is going on here. So right, if I don't use the APT, that's what I deliberately commented out before. So you need to run the test to find the error, right? If I run the test again, it's wrong. But I don't even have to run the test if I use the annotation processor, because then if I redo the compilation, then it actually shows that as a compile error, right? And that's kind of in line with the distinction between like using the annotations versus the aggregate. There's a certain set of verifications that we want to apply to our code base, and depending how resource intensive or intensive that is, how much time does it need to evaluate that thing? It depends on where we want to place it into our like edit compile cycle, right? If it's reasonable, or if it's work that reasonably can be put into the compile life cycle, I would want to put it there because it gives me the feedback earlier, right? And the interfaces here allow us to define like a bit of generics. Well, it looks like a bit of generics kung fu, but it allows us, for example, to detect without any APT whatsoever what I had like not working before here, right? So if the customer ID is not an identifier, the compiler basically tells us just by the pure fact that that ID thing is bound to the identifier type, right? So we're using the type system to let certain rules of our entire rule arrangement be already enforced by the compiler, and for all the things that we cannot express in the type system, we then use either an APT or we use an integration into a code quality toolkit like ArcUnit. The same rules are predefined for things like JQ Assistant, for example, if you want to use that, right?
Does it also work out of the box with IntelliJ?
The question is, does that also work out of the box with IntelliJ? The only thing that would need to work out of the box with IntelliJ is annotation processors, and if they do, then this would work. There's a couple of things. I love the IntelliJ team, and we've just like in May or so we shipped the Spring Modulith support for it. But there's like a couple of tickets on open in IntelliJ that make some of the things that I show you, and I'm going to mention that, not work out of the box with IDEA. You have to explicitly tell IDEA to do certain things, but anything APT works out of the box, right? So I don't want to unwind this. What time is it? 2:24. We have an hour left. Okay, so that's, we've seen more expressive code and verification. To the more expressive code thing, or maybe let me go ahead. Basically, get back to where I started with this. There is this the annotation-based variant and the interface-based variant. Why would I want to choose one over the other? Annotation is not sure if all of you are familiar with that. If you have an annotation on your class, and the jar of that annotation is not present on the class path where you're trying to run that class, the JVM will not blow up with the class not found exception, right? So the annotations are then silently ignored. In other words, you could use the order, whatever jar we're producing here, you could use that on a project that doesn't have jMolecules on its class path, right? If you are a purist and you want to basically be able to do that, then go with the annotation-based variant. With the interface-based variant would require you to take the jMolecules jar, the API jar forward. It's not a huge jar. It's basically, let's go here, and it says jMolecules DDD, and there's basically that, right? A couple of interfaces or a couple of annotations. So it's nothing. It's kind of like a spec, really, right? But it's basically tied around. Okay, here's the blue book. The blue book is the reference, and here is everything in there. Same for events, like the APT thing. Of course, is a compile-only dependency. That's fine, right? So this would be a distinction. The other distinction would be like for APT or not APT is like if you have an existing project and you would like to start, hey, I would like to use the DDD, I don't know, annotations, interfaces in my project and start using them just for the sake of making explicit that order is an aggregate root, right? Because that's an important information. And we don't have to find a potentially existing order repository for that. And you have the APT in place, like all of the code that gets these stereotypes assigned to it will immediately be verified and potentially break your compilation step, right? If you don't want that, leave the APT aside, and then with ArcUnit, you can basically, or JQ Assistant, you can limit the scope of either of the types you check, or with ArcUnit, there is a mode where you can basically freeze the violations. You can say, run this once and document all the violations you find, write them to a file, and you check that into your source code. And then from then on, it will only complain about new violations. So it's kind of like, oh, we know this thing needs to be cleaned up, that code over here, but we want to make sure that all the new code that we add follows these approaches. Right, or these design guidelines. All right, that would be kind of the guidance for when to use what. What do we do here? Yeah, let's go with the next thing. It's going to be the most controversial thing, I guess, and I like good controversy actually. So we've seen that. So eliminating boilerplate. So we've basically got here like, okay, we have these terms of our pattern language available as programming constructs, and we can use them in our code base. That's fine. So we can assign code to our code bases. Now, the next thing that's kind of interesting, let's say we were doing some kind of onion architecture. It's not that's really required in your project, but it's kind of the way we arrange our code, right? We have our domain code at the core. This is where our domain abstractions live, where our concepts or domain concepts live, or rules or business rules, and we have our application area around this, like Spring services, what have you, that implement some validation logic. Is the state transition allowed or not, right? These kinds of things that come from your domain. And then at the outer rim, we actually have this kind of everything that's infrastructure. So from controllers to repositories, so everything that controllers produce HTTP or endpoints to some degree. Repositories talk to different databases. You might have a message broker involved or talking to a third-party API. That's kind of the next thing here. So what happens at the border of the application ring actually is that there's usually some kind of translation which then involves some kind of technical library to do the translation, right? That for, let's say, database access, there's, let's say, Spring Data involved, or in particularly a JPA provider of your choice, or let's say some MongoDB kind of mapping is going on, like this object to a JSON document, the same way that Jackson maybe produces a JSON representation for your API clients, right? And then the question usually comes up that is like, okay, how do we translate one model into another, right? And the most heated debates, there's two heated debates in the DDD world. One is what is an aggregate, right? And the second one is like, how do you map your objects to your database? And there's like two schools of thought here. I don't necessarily belong to one or the other, but there's one school of thought, it's like the more traditional one. The non-DDD folks usually come with the idea of, hey, we have our domain model, and we need to actually load data from a database or persist it into a database. So we have JPA or any kind of other persistence mechanism, and we put the mapping information onto that model, right? So we have a persistent model. The model is persistible as is. The other, let's say, more puristic school of thought says, oh, you don't do that. You don't do that, right? Because your domain model has to be free of technology choices. Playing devil's advocate here. Class is a keyword in Java, right? So it's not really technology free, you could argue, right? You remember the times when we didn't have a proper datetime API in Java, right? So thanks to Steve, we had Joda time. So is using JODA-time in your domain model a technology dependency or not? Right. So what I'm trying to say is there's no real border that you can know. I mean, you could argue for yourself, but I'd argue, where do you draw the line, right? So the other approach is we keep our domain model free of technology as much as possible, and then we have the repository layer or the data access layer to then map that thing onto a separate persistence technology specific model, which then maps the thing again onto the actual persistence model, because that JPA entity is not our persistence model. It's not, right? The database table is. This is the thing that we actually want to cater, right? So what we're doing here, what you're doing with the purest approach, because you of course have to do that for your API clients as well, is you have your domain model at the very center, right? And then your controllers basically map that into another class model, which then Jackson translates into an API representation. The same way you would do that for the manual mapping of a persistence model into a database. And I'd argue this is a completely valid approach for scenarios in which you don't control the actual target model, meaning the database on one side and the API representation on the other side, right? So if the database you write to is used by another team, so it could potentially change when that other team decides it needs to change, then by all means do that, right? Decouple from those changes that you might not control yourself. The API representations, it's kind of the same, right? If you build an API and it's like successful in one way or another, you probably don't know who's actually using it. So you cannot arbitrarily change the thing because you would break, I don't know, thousands of clients. With more modern applications, I think we can take a more nuanced stance on that, because if you own if you own the database, right, then there's no need to actually map between the domain model into a separate persistence model and then to the database, because you control the thing. And then you could also have that other argument that I usually get is like, yeah, okay, but I have, let's say my database table has the column surname, and I want to change the concept to last name, right? And I can do that in my code base, but I can leave my database unaffected. Do I really want that? Do I really want to, like cognitively, right? Or every time I look at my code, see last name, and then in my head map that to, that needs to be mapped to the surname column. Ideally, we all decide as a team that we want to rename that concept, then we want to rename it every place possible. And we actually can, because we own the database in that case, right? And then I just write my bloody database migration script, rename the column, be done with it, right? So it's kind of like, you can have arguments for like both of the approaches, but one of the downsides of the lower approach is that, of course, my domain model does not only necessarily see the JPA annotations. The bigger problem is that it needs to conform to JPA in some very subtle ways that are not represented as annotations. One of those is that, oh boy, there we go, unfold this again. One of that is that it needs a no argument constructor, right? And that no argument constructor has a lot of implications. I've just been recently discussing this with the Kotlin guys at JetBrains. There's no way you can really work reliably with non-nullability information if you need to have a no argument constructor, right? Because then by definition, the object can be created in a state where every field is null. And if you can't really express, let's say, for example, the order ID must never be null, which would be a reasonable thing to assume here or to try to constrain. And it turns out that, let me just jump ahead a slide here. We can actually, before we go to the demo, one second. Let me just finish the thing. So we have a lot of. I come back to you in a second. So we have a lot of like things that we need to put here to get this order class as is mapped to JPA, right? So one to many would need to be because again, the order is an aggregate. Be reminded, right? It's not explicit here yet, but if we know that the order is an aggregate, a lot of these mappings, if not all, are actually kind of a logical consequence of that. There's no question of like, oh, we could map it like this or we could map it like that. Because, for example, the list of line items needs to be a one-to-many relationship with a cascade all, with an orphan removal, because by definition, an aggregate controls the life cycle of all the contained entities. Right? And then we can actually go to, if we use, let's say, jMolecules, we can come from, does that work? Right? So we can actually come from the left side, this is basically the code that you see, and get rid of all of that and add the meta information that's more abstract and basically coming from the domain-driven design world, right? So we basically say order is an aggregate root. We have an association from customer to customer ID, and that we set up in the constructor. Order ID is an identifier, right? And so you see the only thing that's left on the right side for JPA is the table name, because it's a deliberately constructed exception to the rule here, because without any further configuration, order is a keyword in SQL, so we cannot name the table order. I know we can basically just escape the thing, but just for the sake of the example here, right? This class has something that's not quite not quite right with the target model. That's kind of a mismatch here. So we actually use the add table annotation to customize that. So what if I told you that the thing on the right can actually be persisted via JPA as it is written over there, right? That takes away a lot of the concerns that people had when they were like, oh, we persistent models is kind of the bad thing, right? Because there's so many JPA annotations and what have you. You see, there's no default constructor defined, no many-to-one, one-to-many annotation. There's the entire serializable dance for identifiers is gone, basically. And even better, it's actually I should have updated the thing, but actually the order ID could be a record, right? It doesn't have to be a class, so it would even make the definition a bit more concise. To be honest, we could get rid of the add value annotation here. Before I show you how that works, there was a question in the audience.
Basically, when we have the domain,
yeah.
Let's say order domain, it can be as complex. Then if we normalize that to table design, then in that case we will have lots of annotations like this.
Yeah.
We are bringing all the things in our domain.
Yeah. So the question is like when the domain becomes more complex, like we all need all these kind of custom mapping annotations on the class, like how do we deal with that? I guess I somehow already gave an answer to that. The other aspect to that is like if you have a large domain model that's complex, that's a problem in itself. Like not the domain model, but if you have large aggregates with a lot of details, a lot of relationships, that's a problem in itself, right? So the general recommendation is to try to keep these aggregates small and be reminded that, and that's something I see in a lot of like people that do not come from the DDD world, but have worked with JPA a lot. It's like they try to build this one thing that has to support state transitions on the model that's supposed to be, let's use these entity graphs so that we can, let's say, only read partial data. So they basically overload a single kind of class construct with these different responsibilities, and you just don't have to do that, right? JPA perfectly allows you to use to read data into DTOs. So instead of using that class and it's an arcane entity graph definition in 55 annotations, just write that DTO and then basically declare the query to return the DTO, and you basically read just exactly the data you need here, right? So there's a lot of things that you can do just by using JPA in a sane way, quote unquote, to avoid a lot of things here. Similar lazy initialization exceptions, right? Aggregates are constructed, materialized eagerly, right? They are materialized in one go. So there's no need for, let's say, line items to actually do lazy loading or what have you. You just read them, and JPA perfectly does that if you basically use it correctly. And what we can actually do is we can if you don't have to put the annotations, we can actually set it up by default to do the right thing, quote unquote. And I'm going to show you how that works. I just have to find like which of the IDEs, which of the samples would I? Yes, I take the. Let's take the arc-evident example here. That's basically like it's a tiny step ahead in the direction of jMolecules already, but you basically see the same class arrangement here. It's slightly more complicated because I don't have to get it on a single slide, but there's a status thing open. We have these methods here that basically take the aggregate from one state into another. There's a couple of other things going on. There's line items. There's no events here yet, but you see there's no JPA annotations except the add table annotation. But there should be a test case, I think, order integration tests, persists and loads in order. And let me just briefly do that, just as a safety net. And it should actually work. So you see it's green here, right? So what's the secret sauce here? I mean, we do basically simply Spring Data stuff. So there's nothing Spring Data specific that's going on here. What we're doing is, and you should actually see that in here if I use the Maven console and clear that, and I rebuild the project, you see there's a bit of stuff going on. And the secret sauce is that we augment the source code with the mapping annotation. So after the compiler has compiled the class, we go ahead and use ByteBuddy, an ASM library, kind of bytecode manipulation library, to inspect the code base and see, oh, you have aggregate roots in there, you have entities in there, you have identifiers in there, and you have JPA on your class path. So by the virtue of the ByteBuddy plugin declared, we can actually default the mappings for you, and that's what you see here, right? So we find Jakarta persistence. Earlier versions had also support for legacy Java EE persistence. It's not something different, but just like different namespaces, right? And then you basically get what we consider the default mappings here. So we add the default constructor, we add the Java Jakarta persistence entity annotation. There's a lot of nullability verification going on because you can easily shoot yourself in the foot with JPA there, with the presence of a default constructor. There's a bit of Spring Data JPA specific stuff going on as well. So this kind of, the entire machinery takes an approach similar to Spring Boot, right? So you set this up by, I can show you that real quick. There is a ByteBuddy version, yeah. There's a dependency, there's a ByteBuddy Maven plugin, transform extended, class path discovery true, finds the ByteBuddy no dependency thing here. And that's basically then doing, oh, if you have Spring on the class path, we do the right things for everything Spring. If you have Hibernate and JPA on the class path, we do the right thing here, right? So there's like a lot of things also. Hibernate by default, even for one-to-many relationship, creates a join table, right? Whereas most people are usually more familiar or think it's more correct to just have a foreign key constraint in the line item table pointing back to the order, and that's what you have to do to achieve that, is declare a join column annotation. And we can actually do that for you, right? There is a reason for why Hibernate does that, because if you have, let's say, multiple lists in there, that doesn't really properly work. So you can have only the join column annotation if you only have one collection mapping in the entity, and we also consider that, right? There's like a lot of like smarts built in to actually default the persistence mapping. Even better, if you think we're doing anything wrong here, just declare the one-to-many annotation yourself, and then we kind of back off that thing, right? I'm not sure whether, it's because it's been a clean build, it's kind of adding all the things. If you sometimes, there's like, the integration is capable of working with partially compiled code bases, such as when the Eclipse compiler runs, it doesn't necessarily compile all the code, but only the thing that's been changed and affected by that. That's considered here as well, right? You will see, oh, we don't need to declare a default constructor because there already is one, right? That's kind of the thing. So that's kind of the persistence mapping metadata generation kind of approach. What you also see here is something that we do because I mentioned there's general integration of here's your source code, it's enriched with the design and architecture annotations or types, and here's some technology we want to project the integration. We want to make it work with a particular technology. There is, for example, the service annotation here. That's something that a lot of people really are like purists. Oh, why would I annotate my service class with the Spring service annotation? Because it couples my class to Spring. Well, we can have debates about that, but if you're really like, if you think that's a problem, there's the domain-driven design concept service. That's why there is a jMolecules DDD annotation service annotation. So while that's fine, how do we actually now get Spring to consider that class as a Spring bean, right? And there's like multiple ways to skin the cat here. If one would be to just like point the component scanning of Spring to the add service annotation of the jMolecules add service annotation, that would be one thing. The other thing, and why we're using this code generation approach here anyway, is there's kind of well-known annotation mappings really between the jMolecules annotations and the Spring annotations. And then for every annotation we find on the one side, we also add the one on the other side, right? So for the order management, in which we've used the jMolecules service annotation, we're going to add the Spring Framework stereotype service annotation. If we find the Spring annotation, we also add the jMolecules annotation. Why do we do that? We want tool vendors to be able to work with this metadata independent of what kind of technology you're using, right? So if a tool vendor decides to support jMolecules, they don't necessarily have to build like specific integration for Spring if all they want to do is find the services in your code base, right? That kind of stuff. The same for here. The order repository probably is not a Spring data repository, but it is actually, but we add the annotation nonetheless. Okay, fine. The jMolecules annotation, oh yeah, because it's a Spring data annotation, because it's a Spring data repository, we also add the technology independent annotation, right? Is anyone old enough to remember the ages of model-driven software development? Oh, lucky you, right? So for those who didn't raise their hands, lucky you. So there was this kind of idea that at some point we were all just like, I've probably been becoming obsolete with AI these days, but in the early 2000s, the pipe dream was that we would not write code anymore, history repeating itself, but we would just like model software, right? We just create platform independent models, and then we have code generators, see where this is going, to then turn this application, when I tell it, oh, I want a Spring application for that, and then it would basically automatically translate all the platform-independent models into a platform-specific model, like let's say a Spring web application with JPA, and that would do all the things. Similar things, this is kind of a similar approach here. I'm not saying it's ultimately doing that, because it's still very close to the code, right? So it's not like we use a separate modeling approach or whiteboards or draw boxes and lines and into some tool and then generate code from that. We still write code, but we write higher level code that would then kind of be translated into the lower level abstraction. All right, 1433, that's pretty good. Then let's continue with, a thing that I definitely have to mention at this point here. I mentioned before, there is this entire world of the jMolecules specification, quote unquote, right? The annotations and interfaces that you see used here. This is one thing, and all the code generation and boilerplate stuff that I've shown here is a separate thing. So you don't have to use that. If you work with a team that's like fully into JPA, knows their way inside out from JPA, and would rather like to see those annotations. I know people work or think that way, right? If I don't see it, I don't really trust it to be correct. I mean, you already gave that up when you chose JPA in the first place, right? Because I mean, that's a reasonable debate to be had, right? Isn't JDBC something that would be a better use case? That's not up to me to decide, right? But when you don't basically force this onto people that don't think that way, that's a very important thing. And it's something you can selectively opt into if you want, and just like want to experiment with that. The code generation or the mapping code generation is not only available for JPA, but also for JDBC and Spring Data MongoDB, right? Because even, especially with Spring Data MongoDB, it's like a document store, it basically stores tree-like structures, and those tree-like structures usually map much better to aggregates in the DDD world. So there's a much smaller gap to bridge here in terms of mapping annotations, because yeah, MongoDB would just, for the list of line items, it would just basically create the necessary subdocuments in here, right? So all of the integrations I've shown you are optional things that you can pick and choose from depending on yours and your team's liking. Okay, we did that. Yeah, to summarize basically this part, and I have to show you a bit of IDE integration before we go into the break, is so we go ahead and put architecture and design concepts explicitly into the code. We don't, and I'm going to, that second statement is not entirely true, but the ones that we provide, the concepts that you can use out of the box, are the ones that are well established in some kind of literature. The DDD book, event sourcing, and CQRS. There's like, it's not something that we as the jMolecules team really thought came up ourselves. There's always some kind of like broader community around these things, right? Exactly, and then here's the split between the jMolecules APIs and the tool integration. While I'm personally not like involved in anything but the Spring space, and that's why there's a lot of integration is already available for Spring. So most of the sample applications I build are built with this stuff. We have a lot of customer projects that work with this stuff. But if there's anyone interested from any kind of competing technology to do similar things, be my guest, right? So I'm happy to basically guide you through those ideas. But so far, as of today, none of the other coding ecosystems seem to be, Java ecosystems seem to be interested. There's a bit of stuff going on in the PHP world, but yeah. So, IDE support. There's also going to be going to spend a bit of time on Thursday on this topic in one of the talks. Zooming out a bit again, right? So what we've done is we've taken these design abstractions, the architectural concepts, layers and rings we haven't seen so far yet, but we're going to see in a second. And that's kind of our mental model, and our mental model is shaped by that of our code base, and we have found means to put that into the code base. But what's still left a bit undiscovered or unexplored is that when our IDE presents our software to us, our code base to us, it's still stuck to source main Java, right? Folders or packages, right? In your IDE. Let me briefly go here, right? So this is kind of the folder structure over here. It's kind of, that's an abstraction, and we see, we have a customer and we have an inventory repository, but it's not actually working with the terminology that we have in our heads and that we build our cognitive models around, right? So while, I mean, I probably get a bit ahead of myself, but this is a Spring Modulith application. And a Spring Modulith application, this thing is not an arbitrary package, it's a module-based package. So everything under example.customer is becoming a module. And that's kind of the way I think about this piece of software. The other module is inventory, the other module is order, right? And then this thing here probably is let me zoom out. That's inventory, that's a service, right? So that's a service. As you just probably found out by the way I was talking about it, I wasn't really sure because it's not obvious that this is a service. But wouldn't it be nice if there was a way for me to see, my application consists of 3 modules, and in these modules I have services, I have aggregates, I have entities and whatnot, right? And that's exactly what you get with the latest tooling in VS Code. We built that first. It's actually something that's kind of rooted in jMolecules itself. There's jMolecules 2.0 is coming in this November, definitely before Spring Boot, because it all needs to work together somehow. And there is a stereotype abstraction. So we think of these individual concepts like an aggregate root, an entity. These are stereotypes that we assign to our code base. And there's a way that we go ahead. Let me just go here first, just arbitrarily pick one, right? So aggregate roots are defined in some kind of configuration JSON flavor that basically describes, here's a concept, and that concept can be found inside the code base by using some assignment patterns, like here's an annotation or here's an interface. And that's kind of, these definitions are shipped with the individual jars. So that JSON file here is part of the jMolecules-ddd jar file, right? And the IDE can actually use that information and build up a project tree that actually works with exactly these concepts, right? So depending on what jMolecules jars you have on your class path, and in this case it's a Spring Modulith application. It's something slightly odd, but it's like separately detected by the IDE. So we have these like Spring Modulith modules, and then if I use the jMolecules DDD jar, I will find like all the concepts that are coming from domain-driven design, right? If I go ahead and let me open up another project for you that's also using the jMolecules DDD abstractions, but it makes some explicit assignments to hexagonal architecture abstractions. Then what you get here is not only the modules, but wait a second, what am I doing? Oh yeah, I think I've flipped. You can basically select those. Yeah, I have to activate this. Then you get all your application code kind of not implicitly assigned, but there's like an annotation on the package that says all code that's in here belongs to the application hexagon, right? And the primary ports are services, right? And the secondary ports is a repository, and it's a Spring one here, and it's like 2, right? So when you're working with these design abstractions, there is already the IDEs using that information and basically present you the project in a way that it basically allows you to think and also browse the project in that way, right? The icing on the cake, I think, is that especially in this project, what you can do is you can define your own, because there's actually been a blog post by Stefan Tilkoff. He basically, there's some criticism he had with domain-driven design, and one of the things was that the book, especially the blue book, kind of implies that the stereotypes that are defined there are kind of the whole thing, where it's actually the ones that Eric was kind of aware of at that point in time. It doesn't mean that there's not other concepts that you identify when you're working on your code base that you would actually or can actually name like this, right? In this case, let's say we want all our form backing objects, or we have forms, some concept called form in our application. I can just annotate it with the @stereotype annotation, and that would make. Let me just disable the hexagonal architecture stuff again. Then I much more easily find stuff. There's forms here. Right, and then if that's I think used in the controller payment web. There's probably a form object down here somewhere here. If I basically change that to that, this thing is gone from here, right? So you're free to come up with your own stereotypes, your own high-level design elements, your intentional design elements, right? As we defined it in the very beginning, that you say, here's a concept that we share within the team for the project. That's some high-level thing that individual elements of our code base could actually be assigned to. And then there's like rules attached to that. You probably have to write your ArcUnit rules for that then, but you can already like browse and explore your project, find these things in your code base. So I'd be very interested how people react to that. So it's like a prototype. It's not even, you can, if you switch to, where am I? If you switch your Spring Boot tooling to in VS Code to the pre-release version, you already get that, right? And if you throw in a project that doesn't know anything about jMolecules, you still will get some kind of technical abstractions. So all the Spring specific thing here, like the repositories, the controllers, configuration classes, also Spring Boot specific stuff like JSON mixins. That's some technical concept that Spring Boot comes up with. It's an annotation, and that causes the framework to do certain things, but it's something that will explicitly be called or listed out here in this thing, right? So like exceptions is even coming from core Java. You don't have to do these things. And just to round things off here before we go into the break is the one thing that we're trying to achieve with that is that people often, or teams often use packages to achieve exactly that, right? How many times have I seen yada 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 my project dot service dot persistence dot controller dot something something, right? So people already group code by stereotypes, and you don't have to do that anymore because, right, you get that discovered from your code base without you having to abuse, and I say that deliberately, abuse packages for that kind of, for like grouping code by stereotype. And why this is a problem, I'm going to discuss in the Thursday's talk, domain-centric, what have you. There is also, there's a similar plugin for let's go back here. It's a similar plugin for IntelliJ. That's been like some member from the community who wrote that. You see that it's taking a slightly different approach with the labels up here, right? So it's kind of labeling the things. That's kind of an interesting additional way, but it also had this this kind of a first idea, a first draft of that kind of grouping in your code base. It's not really well maintained. That I have to admit that, but the next thing after I've kind of helped the IntelliJ team to build the Spring Modulith support for that, which you're going to see in the afternoon, in the second part. The next thing we're going to look at is to bring similar things to IntelliJ itself, right? With the same foundation basically built on. And with that, yeah. We've seen that, right? That's kind of, sorry, I got ahead of myself, but stuff leaves me excited. We're basically done with the first part. I have, let's say, 2 to 3 minutes for questions, like if you want them to appear on the recording. I'll be here. Let's start at 3:05. Let's restart. I'm happy to answer questions in the break, but thank you for your attention for now. All right. A lot of people are back. I'm happy you didn't run like out in hordes, actually. So I'm not sure if we really have to summarize the first part of the talk. You've seen like how to express design and architectural concepts in your code base and what you can achieve with that, right? So you can verify the arrangement, the structural arrangement according to the rules associated to the stereotypes. I showed you a bit of the integration possibilities into certain technologies like Spring and the persistence, and that was the last point actually. So we're going to zoom out a bit. Wait a second, I have to. I need to move that window over here so that I can see where we are going. Oh boy. All right. So, before we talk about like Spring Modulith in particular, the broader topic here in this part is we have until 4:30, right? So just for my inner clock, basically. Before we talk about the technology and the ideas behind Spring Modulith, I want you, and I hope that I got this across from the first part. because I talk a lot about applying the concepts to the code base, there is certain technology involved here, but this is not the most important bit of the talk. I really want you to basically get your mindset into that direction of thinking in these abstractions. And for this particular part, that means thinking in modules in units of functionality, right? So while Spring Modulith is probably the closest technology to my heart these days, it's not the thing that it's at the center of the focus, right? So what does a modular architecture look like? So I take the onion architecture example again, because it's particularly important. It's not actually not important at all. It's just like we have some kind of assignment of code bases to certain areas, logical areas of our model, right? So we have some code that's core to the domain, or core abstractions, entities, value objects, aggregates, what have you. And then there's this application ring around it, which is more like use case oriented, like what can I do? I want to book some travel, I want to place an order, these kind of things, right? So there's like functionality that's probably coordinating a bit of the abstractions in the domain core. And then there's the infrastructure part that exposes that functionality into a certain protocol or what have you, right? It allows you to receive events via messages. It produces HTTP APIs, what have you. The important bit about this kind of approach is that you have a outward in dependency direction, so you can reasonably verify that your code base adheres to that model, right? In a Spring application, long before anyone talked about hexagonal or onion architecture, we were placing @controller classes in the infrastructure ring that were talking to @service annotated classes in the application ring, which were using domain abstractions from your customer, zip code, what have you, right? So that's all nothing really new or fancy, right? It's just one way to think about like your application. As I said, right, web page, server-side rendering, APIs, messaging, and databases in the lower part. So still, like all of these rather technical architectural approaches, hexagonal and onion, they are like very popular these days. It probably also came with the advent of microservices, but people sometimes, or I see teams that see those as this is the way we modularize our application. So we have our infrastructure module or application module. But I have bad news, but none of these architectures have anything to do with modularization. And why is that? And I think there was a tweet recently, or not on Twitter anymore these days, something on the interwebs, where basically, and that's kind of the premise of the talk on Thursday, these architectures are called domain-centric architectures, right? And that means, for most people, that means the domain is at the center of the entire logical arrangement. Well, that's kind of true in that visualization here, but in most projects I see the separation of the domain into individual parts, right? Separating everything that's related from orders, to orders, from everything that's related to the inventory. That's the core challenge, right? Functional decomposition of your system is at the core of maintainability of software, right? And unfortunately, as domain-centric as these approaches want to be, all of them ignore that problem completely, right? So the domain is something that's one single thing at the center of it all. So you could argue that they're kind of missing the problem here, right? They're solving a problem that's not the primary problem these days anymore. To their credit, they've all been come up with the early 2000s. I think hexagonal architecture is from 2005. Onion architecture is a bit later. But they were all concerned with separating the domain code from the infrastructure code because of testability, right? Because back in the days, when we were bootstrapping application servers and then grab a coffee until that was finished, that was an important thing, right? You wouldn't want to wait to verify any kind of change you make to your software using the entire or bootstrapping the entire machinery. And by separating the domain code from the infrastructure code, you achieve that. And heck, this was one of the core things that Rod and Jürgen started or put at the center when they were starting Spring, right? Being able to unit test classes individually without bootstrapping a container. So, but once we basically come to agree that, okay, we actually have multiple domains in our system, right? We have our order, we have our inventory, we have our customer thing. So how do we make that kind of separation fit that picture? And the idea that I kind of came up at some point, I think it was 2 years ago roughly, was like, okay, if it's like, what do you usually do with onions? You cut them, right? And there's tears involved with that. Pay attention. So when we cut the onion, the application ring gets this kind of edge here on the outside, right? And when we have these cut onions, we can actually put multiple of them right beside each other, and then we can package that up, and that would actually be a kind of nice way to kind of organize our code within a code base. Even better, because that gives us the ability to let these things into these individual sliced onions to interact with each other by, on the application ring, expose either Spring Beans, right, like instances that someone else can invoke, or publish events. Right, that's kind of the typical things that you do within a Spring application, right? So that's what you would do. So the interaction would not like in contrast to having full onions like for each of the 3 columns here, that would then need to go through the infrastructure ring into the infrastructure ring of the other thing, and then do some kind of mapping and what have you. We can just have Java code on the edges of the application ring, and then basically let those interact with each other. Taking one step further, whether that's onions or whatever happens in there, doesn't really matter, right? What we think of is we have individual modules in our application, meaning we have some way to kind of put up some kind of boundary in our code base and allowing us to design the surface of that boundary. So we can and we have to explicitly decide what kind of code and API we expose to other modules. Also, that's not a first that someone thought about this, but okay, this is kind of the fundamental thing. Whether you use hexagonal or onion architecture inside of these modules totally becomes an implementation detail, right? And it actually might be the case that let's say we have a very simple module, something that just like needs to provide reference data to other modules, what have you. So is it really heresy to say, oh, we have a Spring controller, and that gets a JDBC template injected, and then just a select star from yada, yada, yada? Is that really an architectural problem? If you believe the mantra of like hexagonal architecture, it certainly is, right? There's a primary adapter using like the database directly. Oh, you should not do that. You have to put a service port in between, then some application code, and a secondary port, and then a JDBC adapter, what have you, right? But why, right? If the domain of a particular module is simple enough, just go with this most simple thing that you can think of. And if you have to like interact with a third-party payment API, oh, that might actually be a very, very good use case to have an actual adapter with that API and the port, and then making sure that your domain logic only interacts with that third-party API through that port. So the complexity of the domain determines what kind of abstractions we need within the module, right? So what does that look like in terms of actual code? I actually don't want to spend too much time on slides here, but rather show you how that works. We are slightly off here, so we take that. So here is the thing. It's like the Arc Evident Spring application that I have. It's like a very simple thing that basically there's no meat in here, no actual business logic. All I'm trying to establish here is, this is the way we can define these buckets, these columns, and here are the ways that we can actually hide things from other modules and define our APIs, right? So the order thing, there's an entity in here, if I zoom in that much, I can probably go here a bit. So it's the aggregate root, right? You've seen all the jMolecules shenanigans in the first section. There's a service, and we have our use case here is the complete order thing, and that's kind of invoking the inventory and basically tells it to update the stock once the order's been completed. We get into the specifics and the nitty-gritty details of all these interaction kind of things later. But what we get here is a piece of code that basically says application modules off, and then we point that to our central Spring Boot class, right? So it's this one here. It's nothing specific in here. It's like a just standard Spring annotation, main method, what have you. And then what we can do is we can actually just output what we find, and you will see what's going on here, right? So what happens under the covers is that we use argunit. It's I mentioned that in the first part of the deep dive already. Oh boy. And let me zoom in this way. Boy. Right? So we use argunit under the covers and scan the entire code base, like not the entire code base, but everything that's residing in the example package here. And then the immediate assumption or the default assumption is that every direct child package of the root package or the package that we find that Spring Boot class in is the module base package, right? So it could be one, just like this here. So we can actually fold everything into one package. That's fine. And you see there's like a lot of information, right? There's a logical name to it. There's a base package. Sub-packages could be excluded. We have dependencies between the modules. So order has a dependency to the customer package on the entity basis. So it's kind of like just referring to another type. And it also has a Spring Bean dependency. That's the plus here to the inventory, right? And there's a couple of like Spring Beans in the module. This one is public. That's why it's plus. And this is this is a package protected thing, right? So we kind of already have, without doing anything Spring Modulith specific, we have established this kind of notion of here's a module and here's an API for that module and here are the internals by simply using Java standard language means, right? So the module became a package and the public types in that package became the interface, and the everything that we want to hide from the outside is something we can actually just make package protected. By default, and I wonder if that's a good. Where do I have? I didn't open that up, but I should have idea here, right? So there's speaking of IntelliJ, the latest version of IntelliJ actually has support for Spring Modulith, showing you the module packages with that kind of green open lock here. So it basically says that it is a module, and there is any kind of, if I do a new, how do I do that in IntelliJ? Java class, and say call this foo, and then how do I move this into a, I'm not an IntelliJ guy. How do I move things? Refactor, move class, and then basically say inventory foo. Yeah, please create that for me, right? Then you should see that here, this thing is becoming red now, right? There's a red closed lock. So the convention is that by default, all the sub-packages of the module-based package are they contain, or they're not accessible to other code as well, other modules either, right? So something, if I went ahead and from the, let me just make this way here, and zoom in a bit. If I go to, where's the orders thing here? If I take the order management and the inventory has this public thing here, I put the public type foo into inventory foo, and if I now go private final foo, this should be red. I probably have to import that. Yeah, and then it's red, marked red, and it says module order depends on non-exposed type, yada, 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 inventory foo from module inventory, right? So IDEA kind of understands our modular arrangement and immediately marks this thing as problematic, right? So, and it also gives you a couple of like things or suggestions of what you could do, right? If you really want to refer to that thing, then it needs to become part of the modules API, which in this case would be either be moved to a base package, or I think there's probably, yeah, you can have a dedicated annotation on the type that would elevate it into the API. More on that in the Spring Modulith talk on Thursday. Let me just remove that. Yeah, right. So that's kind of the stuff you get in IntelliJ with when working with this. Where is my other ID? Here, there we go. Right. So the thing is that this is kind of the module model, and we have a verify method here. So you can actually, in this case, it should quote unquote not do anything because it's just a valid model. But the verification. Wait a second. I have to update this. Should be good. Why is it still red? Why is it still red? Thank you. That's so-called crowd computing. Have you heard of that? Yeah, right. So it's kind of you would get the same. I mean, this was the IntelliJ support that you've seen before. But if you also want to get this kind of modular structure verified during a build, and that's why you call this modules verify thing for. So it would basically have revealed the same problem that you access some internals here. All right. So that's fine. It's kind of it's a slightly different approach than with jMolecules, where everything was about being very explicit about the things, the design elements, right? Here we took a slightly different approach, primarily because we want to be the entry barrier was supposed to be very low, right? The production code doesn't know anything about Spring Modulith. It's just laid out in a particular way, right? So you could even start with Spring Modulith in an existing application by only adding it as a test dependency and then running basically the verifications. And you don't have to ship Spring Modulith as part of your runtime arrangement, right? The runtime application is still a standard Spring Boot application. There's nothing special about it as of now, right? There's, of course, runtime specific features, but like the fundamental modular arrangement verification, that's not something that you would necessarily need to deploy to your production code. Because we think that like once in your build, you've verified that your modular arrangement is satisfied and the constraints are satisfied, then there's like no further need, at least from that particular point of view, the point of view of I want to keep my application sources modular, right? It's like a completely different beast, and probably a couple of people are probably thinking like, why not just using the Java module system? For one, it doesn't solve like it doesn't solve many problems that we would like to see solved in the thing that we're doing here. And the other thing is we don't want this thing to be invasive into like any transitive dependencies or something. That's not our goal. Our goal is to help you basically define the structure that you want to see in your application and then control that, right? So that's one thing. Let me just briefly check where I want to go with that. Yeah, okay. So one thing that this is helpful with, and I talked to somebody in the break, and I was like, when you look at the means that the frameworks usually provide with or structuring means, let's take Spring Framework for example, right? You have controllers, we have services, we have repositories. That's kind of a layered approach to some degree, right? We put some dependency injection magic into it, and then we the object web basically gets constructed and brought to execution. But so far, and the reason that these annotations exist is that the framework is interested to apply services, quote unquote, technical services to these individual layers, right? For the repository layer, we want to provide exception translation. For the service layer, we want to do transactions. For the controller layer, we want to provide request mapping. So this is kind of the focus of the frameworks. And that's been that way because there was no way for the frameworks to basically get some kind of verticalization going on, right? So orders versus inventory versus customer. And the question is like, what can you do with this information, this additional information of these verticals inside your code base? One is that we can go ahead and for the inventory, for example, we can, instead of using the probably known @Spring Boot annotation, we can actually say, oh, we want to bootstrap that module only, right? Where Spring Boot, again, technical framework, has annotations to, in test cases, only bootstrap the persistence layer, right? Add data JPA test, or the web layer with add web MVC test. Because it can refer to these technical abstractions and these the annotations at controller, at repository, what have you. Whereas with the assumption of, oh, here's some Spring Modulith structure going on, we can actually run the inventory integration test. And you see, but I mean, the test is not really testing anything functionally, but we say, okay, we expect for this case, for this test case, the order management class or the instance not really being created, right? So, and that's what's happening here, and you see that in the log output. We say we're bootstrapping the application module test for inventory, and then we basically build up our entire application module model. We find that the test case is located in the inventory module. That's why we bootstrap that one. And then the actual magic happens here, right? So we kind of tweaking Spring Boot to bootstrap, but constrain the auto configuration and the component scanning to the exact package that that we have in place here, right? Or that we're trying to bootstrap, and that works for now because let me jump back here. Let me go here and then find my way back. Because here, right, we're kind of, the module that we would just bootstrap was basically like the left one, right? It doesn't have any outgoing dependencies. It was just like, we didn't even talk about events, but it was kind of entirely self-contained, probably due to the fact that it's so simple and it's kind of an example project anyway, right? But what happens if we, if there is, like, if we want to bootstrap the module in the middle here, right? And it has a reference to another module's exposed Spring Bean. This way. So that would be the order integration test, right? If you go to order management, you see there is a reference to the inventory. And I guess what you would expect now is that if you, let me just break the thing to show you the thing here. So if we now run the test and we basically go ahead and say, this is what happens here. You've seen that before. So the test is located in the order module. We want to bootstrap the order thing. We basically reconfigure the entity scanning and the auto configuration component scanning to example order. And then it breaks, right? Because our order management has this like constructor argument of inventory, and there is no inventory instance because that part of the code base is not included in the test run. And that's actually what you get here as a message, right? I mean, there's all the log output here, but you see parameter 1 of constructor order management required a bean of type inventory that could not be found. So what do we do in this case, right? If we still want to bootstrap that module, so we have two options here. One was the one that I commented out pretty quickly. This way here. Oh, come on, that would be the thing. This one, right? So we can use a standard Spring Boot mechanism of mocking a bean, basically. This would take the application context and add an additional bean, or replace, if it already existed before, it would add a new bean of that particular type. So we kind of find out, oh, our module has a dependency onto something else, so we mock that, right? It's very standard approach. If you test a microservice and it has a dependency on some other service, you could just mock that thing, and then we can run it and inspect to green. Right? So we bootstrapped our module and basically replaced all the interaction points with the outside world, quote unquote, with mocks. The alternative to that would be, if I just redo that, would be that we can actually change the bootstrap scope. So we could say mode and say bootstrap mode all dependencies. So what does that do? Like from the graph of our application modules that we build up, we basically just pick the node and then include all the dependencies that are reachable from that, right? That we find out to be useful. So we again report that we want to bootstrap the order thing, and we now include the inventory, and that's in this case it, right? So it's basically now bootstrapping the two modules, but we don't have to explicitly state which ones, but just run this thing and basically bootstrap everything that this thing needs, right? So we kind of align our testing strategy really with the verticals instead of anything horizontal here. That's the thing. The other thing is that we can use. Wait a second. Let me just go to the summary here and test support, simple rule. Yeah. The other thing that's kind of just very, very immediate, and for everything else, I probably refer to you to if you're interested is what's new in Spring Modulith talk. The other thing is that, and you've probably seen that I've put up a website here that has this kind of like beautifully looking UML diagram. But what we can actually, like, if we can technically reason about the structure, the functional structure of your application, we can actually expose that as well, right? So this UML diagram can actually, or is derived from a code base that's a Spring Modulith project. It's the diagram for a project I'm doing with a local university in Dresden, where we let third semester students write Spring Boot applications just to entertain them quite a bit, and they entertain us by doing so. They have a half of a semester of Java before that, and then they're supposed to build Spring Boot applications. So it's really kind of a deliberate kind of overwhelming them with. But they are incredibly great. We're just starting the semester, and it's always nice to see when they come out of the semester and when they have their defenses of the project that they've then submitted at some point, to see how like incredibly excited they are. Like, oh, we didn't know anything about this before, and then now we do. So there's this library. It's about like an e-commerce system that they have to write, basically a pizza ordering thing or a cinema or what have you. And we provide them with a tiny library that you see. There's like orders, there's products in a catalog, there's payment, there's an inventory. You see where this kind of stuff is coming from. So we can actually take a code base and produce such an graphic from. The default actually is Simon Brown's C4 model. But this is a university, so they prefer UML, and then there's like a flip that you can switch to whether I render a component diagram or a C4 model component diagram doesn't matter much. That's kind of nice, right? Because it already reflects what is, not what somebody originally thought of would be, right? So it's correct by definition, but it's also a bit overwhelming, right? Like you see, there's like differently qualified relationships between the individual modules. So what we also render is for each of the, and that came from that project really, because the students were like, well, that's kind of nice, but to understand or to find out what I need to understand, it would be much nicer if there was basically the graph, taken each node, and then all the dependencies of that thing. Literally answering the question, if I want to change something in the inventory module, what other modules do I need to sort of understand, even if just superficially, right? How does it relate into the picture? Like, what's the knowledge graph, basically, that I need to prepare? So we can also produce kind of excerpts from the model. And the next thing, and that's kind of, I think, the most interesting one, is that we can look at the particular modules here, the inventory, and then we, by the virtues, and this is basically where the two parts of the talk connect, we can find architecturally or design or interesting things from an architecture and design perspective on the surface of that module, right? So we can basically look at what's the API of the module, and we can report that. And we can report that in a not like, let's say, technical way, but rather, okay, here are a couple of Spring components, which means that I can write code where I can get these things injected, right? Or here are the aggregate routes, inventory. You don't have to understand them, like what is a multi-inventory and a unique inventory item. Doesn't really matter, but we can actually pull these out of the code base and pull out only those things and not the 50 other things that are part of that module and that are internals, that don't have to be reals. All right, which events do we publish, or does that module publish? Which events does the module listen to, right? So the inventory apparently is interested in order completed events, right? There's like, for some reason, I think the build has failed to some degree, but what we usually do, the event listeners are Java methods, right, in that very code base, and they usually have some Javadoc attached to it. And then we can actually extract the Javadoc from that code base and then put that here so that we could go and say, you could see, oh, this module listens to the order completed event, and that's why, right? If that person that wrote that method would have bothered to actually put some Javadoc on that method. But it finally pays off anymore because someone's actually reading or could actually read that. You see the same thing for Spring configuration properties, right? Because that becomes part of the module's surface, right? I can tweak the module's behavior by setting the inventory disable updates property for whatever that means, or the restock threshold, right? So that's kind of the thing. And what we also nicely do is all of that is backed by ASCII Doctor, by the way, so we only generate ASCII Doctor snippets, and then this is then turned into some HTML page, as you can see here. And what you can hand into the ASCII Doctor generation is the base URL for some Javadoc, so that you have a nice gradual kind of step down from, oh, this is the inventory module, that's how it fits into the overall arrangement. This is what its surface looks like, but if I'm interested in the multi-inventory item, I just basically, it's the next thing about here are the methods that thing has, and yada, yada, yada. Right? And again, the best thing about it, I think, is it's by definition correct in terms of, not necessarily entirely correct, because you see there's a Javadoc missing here, but it's reflecting the state of the source code, yeah, by definition. That's kind of the thing. And that's fundamentally what we have with Spring Modulith at its core. For everything else, wait a second, yeah. For everything else, there's a lot more stuff to it. Things like you could observe the interaction between modules at runtime using observability like APIs, and then pipe those things into, let's say, a Zipkin. These kind of things. That's like all more advanced stuff, so verifications at runtime, what have you. But ultimately, this is what we have with Modulith as a kind of application level module system, to be precise. Okay, I think we're going to. I had a few slides on the documentation thing, but I already prepared that on the slide. We've already talked about that, looking at the website. Maybe let me just go to the demo and just briefly show you where the stuff lives and how you in the modularity tests this is the way you would actually create that, right? So it's the final call here is basically you just wrap the modules instance that you created in the first place with a new documenter, and then it's like write documentation. No AI, is like all just procedural code, but like when I was like 20 years younger, then this would have been my pipe dream of me. Here, take the code base, just write some documentation. That's kind of nice. And that then generates some in the target folder here. Let me refresh that. So there is some Spring Modulith docs, and you see there is this all docs. That's basically just an aggregator document that pulls all the things together, and then the individual plant UML documents and ASCII doctor tables. It doesn't look anything exciting for that very toy project here, because that's not really built to make that shine really. But that's kind of the snippets that you get, and then you would write your custom documentation and include the snippets in all the right places. Right? So what you should take from here is just in line with the first part of the presentation, is that there is value in putting these architectural abstractions, the functional decomposition, to make that obvious in your code base. We've done this here very implicitly by just using the package conventions. You can take this further. You can have, I'm not sure, do I have the package info Java here? Right? You could go ahead and basically make that explicit by saying this is an application module, so you can be very specific about the modules that you want to expose, and you can also be explicit about like what are the allowed dependencies and what are not. So right, if you just basically say here, if we only allow customer to be an allowed dependency, then I think the modularity test, this one here, should fail, because we have a dependency on the inventory, and then yes, module order depends on module inventory via order management. Right? This is you would get the same error in the IntelliJ flavor of that. You would also get like the inventory thing in with red squiggles. I think, let me just check. I think that's working in. Does that work? I'm not sure. It doesn't work in STS though. Okay, fine. Bit of work to do, right? But you get the test, and then you can be as specific and as explicit as you want to be with regards to the module model, right? That's kind of as I mentioned before, we would want to be the Spring Modulith stuff be as applicable to existing Spring projects as possible. There's also a way to tell Spring Modulith, oh, please ignore 90% of my code base and only use that package as a module, right? So if you have an existing project that's likely not going to adhere to that kind of packaging convention, then you can teach Spring Modulith like where in your code base we find modules, and then you could go ahead and like verify dependencies between those. I have a bit of more in-depth stuff about named interfaces, nested application modules in the talk on Thursday. So the interesting, the wrong direction again. There we go. So an interesting question, like let's say we now know about the how to establish the buckets, right, the modules, and we also know how to like basically design our modules APIs by putting code into the module base package or explicitly exporting it. Or we haven't really talked about, or we already hinted at this thing a bit when we were like trying to bootstrap individual modules. The way that modules interact with each other suddenly mattered, right? Because we had to, whenever there was a direct invocation, we had to take care of that during the test bootstrap by either putting a mock in between or bootstrapping both modules at once. So let's zoom out a bit. What's at play here? So the usual thing that, or something that's very usual that you find in Spring applications, that you have some external incentive or kind of stimulation of your application, right? So a request comes in that, I don't know, wants to submit an order, right? So there's some primary functionality being triggered by that. But in many cases, actually in most cases, that's not it, right? So there is some secondary functionality that's attached to that primary functionality, right? So for the order submission, we have to update our stock. So I buy, I don't know, 42 TVs in our e-commerce system, so someone needs to be notified in the inventory. Maybe we have to even check whether we still have 42 TVs, but you still have to update the stock. I probably get some bonus points through our rewards program, and I want to get an email confirmation for that. So that's kind of it's somehow related, but it's not necessarily the core of our business, right? I guess updating the stock is core to our business, but the bonus program, I don't know, right? Yeah, so what I'm trying to get to is there's some different levels of severity to one of the secondary functionalities failing or not failing or this kind of thing, right? So the way that we bring those pieces of functionality together, I mean, you've just seen I've already kind of, basically put one of the functionalities into the inventory module, right? I created these logical units. And the way we, especially Spring developers, are used to kind of then bring these things together is through the means by dependency injection. Because for now, over 20 years, we've taught people that's how you establish like connection between different parts of your code base. Right? You inject the service into your controller, you inject the repository into your service. And it's very, very understandable that like many people just, for them it's like, okay, this is the way you do it. There's no other way. This is the way. Right. So that's why you do, like you have these modules expose Spring Beans, APIs, and then the primary functionality basically invokes those. So what does that look like in code, like in our arrangement, just like stereotypically? We have our class, right, our checkout, let's say a service, what have you, in our application. And we have there's some technical decomposition going on. So we have, in this case here, the repository, because that's a Spring Data repository. And then we have our primary functionality being implemented here. So we have this order complete thing. Where is that? It fell asleep. Yeah, there we go. Order complete, right? So we have our aggregate here. We have a state transition that basically changes the state from uncompleted to complete. And then we confirm that thing with the unit of work, so to speak, right? We say, repository, please write this new state to the database. There's a transaction surrounding the thing, and then we're good. So how does this secondary functionality get basically integrated into that? So usually that's the state transition, internal technical composition, I said that. So usually what we have is these other classes exist as Spring Beans in some other place of the code base, and then we actually inject those. We use dependent constructor injection into the kind of calling code, and then we call that secondary functionality afterwards, right? And we've already seen in my integration test example before, we've already seen a problem, quote unquote, with this, right? Because the more of the secondary functionality we need to integrate with, the more of these things we need to mock when we write tests. I'm coming back to tests in a second. But one question that I sometimes get when I look at foreign code, like code that I haven't written, like when I work with customers. Like, in this thing down here, does the order matter? No one knows. That's kind of the thing, right? So this imperative way of integrating things it sort of implies some order, but how do we know? Is it really important? Is it not? So the important thing about it, like independence of the order, is that with this setup, if there's like, let's say, none of these methods that we call here is special in any kind, means that while we have a nicely structured modular arrangement in our code base, right? So we have the individual modules. When we execute the code, it's still a giant one thing, for better or for worse, right? Because you could argue, and that's probably why it exists in that way, add transactional just expands because the invoked methods just take part in the existing transactions by default, right? So it's a very convenient model for developers to create strong consistency, right? If the update of the stock fails, our transaction rolls back and our system is in a consistent state. If we cannot register the rewards points properly, we roll back everything and then we're good. Same for sending out that notification. But let's say you have the team that does the rewards program has a really bad and ugly bug in the latest state of their code base, right? This also means that we cannot accept any order anymore. So do we really want to get a bug our secondary functionality in the way of the execution of our primary functionality? Question that needs to be answered, right? And that could then lead to different kind of ways out of this. So what I'm trying to say here, this is fine, and not this is fine in the dog sitting in the fire kind of place, right? If that kind of arrangement doesn't cause you any trouble, any headaches whatsoever, this is good. It's not a bad place to start with, right? Because you have that structural arrangement, you kind of have made sure that this is an acyclic graph, the interaction between the modules, that's good, right? So, but what we actually have gotten without maybe us noticing is that our transactional scope still spans all the 4 modules. So it's like one giant thing. And the more, and that's probably a thing I think you might find in your applications as well, is the more features we add, the more likely it is to have yet another of these module interactions included in here, because there's usually these pivotal events, quote unquote, in applications, right? They have, I usually use the term functional gravity. Like a checkout in an e-commerce application has functional gravity, meaning it kind of adheres more secondary functionality, right? So this problem is going to become bigger, right? Over time, usually. Usually, the e-commerce systems don't even start with a rewards program. They just add that at the later stage, and then you add another dependency and another dependency, and so on and so on. Right. So, how do we test these things? Right. So that's what we've already seen. So one of the options to integration test that would be to now mock the secondary functionality. Right, so we have this, the collaborators are mocked, and then at some point we do the given when then thing. So here's an order. When the order is, or the checkout is triggered for that order, we want to make sure that the update stock method is actually called, right? So we're testing for the orchestration to happen. And these tests, they are kind of I think someone used the term, they are ossifying the code base, because they're kind of replicating the arrangement of the production code, right? Whenever I add a new dependency and an invocation, excuse me, this will show up here as well, right? So we're replicating the same thing here. And the testing is focused on the orchestration, which is fine, but you could also argue, I mean, this is this kind of like devil and angel kind of thing. The devil could also argue, like, why the bloody hell does the checkout team have to know about all the other things that need to happen when we're performing a checkout, right? And whenever someone tries to attach a new functionality to that operation, we kind of have to go and then put our dependency onto that thing in our code base and then trigger that other thing, right? And be at the mercy of the quality of the code at the other side of the fence, whether our stuff still works. And that's kind of the way you could at least reasonably look at it. I'm not saying that it necessarily have to be this way. So, right. So the other thing, or the thing that we could try, and this is something that people, or not many people in the Spring ecosystem are familiar with, is that we could try events, right? So instead of referring to the other things and having to refer to them and having to invoke them, we could let the checkout basically signal, oh, here's something that happened, and the others could just react to it, right? So this would look something like this in the code base. So our code base would change to the following. So instead of having all the other dependencies injected into this thing, we inject an application event publisher and perform our primary functionality as before, and then signal, oh, here's an order completed of order get ID 4711, whatever is coming back there, right? And the other code would need to be refactored to, instead of exposing a method to do something, they just wait for the order completed event, and then inversely, probably the inventory would look up the order, find the elements that are in there, the line items, and then basically process the things here. Right? So that's the secondary functionality. So essentially, that's basically a just a glorified observer pattern, and it actually keeps the invocation order the same. So events publish event, this call here is not coming back before this one has finished, which also means that if this thing here throws an exception, we still break the transaction. So we have changed the interaction model, but we have not changed the consistency model. Right? Still strong consistency across all the modules. But it actually has an interesting effect on the way we test this stuff, right? Because we're now not testing for orchestration anymore, but we only test for, once we invoke the method, given when, then we expect that here's something that's called assertable application events, has an event called order completed, and that's kind of matching some criteria. In this case, it's that we need to make sure that the event was published for that particular order, right? So the way I like to talk about this is that the side effect of this thing here ends within the module, right? So we're not kind of reaching out to everyone, tell everyone what to do, but we only test for the effect that has happened inside the module. There's probably some other verifications going on. Has the order the correct status afterwards, what have you. But in terms of the interaction, that's it. So this is, if you run the test as application module test, you automatically get this kind of the ability to inject this assertable application events. With you can also do that without Spring Modulith. That's one of the features that started in Spring Modulith and has made its way back into Spring Framework. There's the @record application events annotation that's supported by the Spring Test Context Framework. I think that the type is slightly different. It's not assertable application events, but it's a similar name. But the idea being, you write a test by invoking, stimulating a module, and then like verifying the output. Of course, that has to be augmented by another test that would then verify that the inventory would do the right thing, TM, when an order completed event is published. But we get to that. We get to that in a second. Okay. Yep. Yeah. Right. So the approach changes from testing a signal versus the orchestration. All right. So that's that. Technically, the way this works is that you saw that we injected an application event publisher, and that was then notifying, that's the publisher, is the speaker here, and then it's basically synchronously calling the event listeners in the other module. So again, to summarize, we have a change in the structural arrangement, which changes the way that we test the thing. But we have no change to a consistency arrangement, right? So if you find yourself like stuck in mocking 15 collaborators of your component, then think about like which of these interactions could become event-based interactions, and then publish the additional event and refactor it to that, and then the tests might just become a bit slightly more approachable, right? So unfortunately, there's more problems to solve with this. Right? So I already spoke about the transactional boundary basically surrounding like all of the elements, and that's kind of okay-ish as long as we all talk to the same transactional resource, right? So let's say a database, right? The checkout is performing a state transition, which probably will result in some database interaction. The inventory updates the rewards program as well. That said, the notification thing probably talks to something else, right? An SMTP server trying to send out an email and what have you. So the question that comes up is like, what about the resource management and consumption, right? If the transaction stays open for the entire interaction, it also stays open while we interact and communicate with the SMTP server, which could be quite a few milliseconds, right? In which we actually don't necessarily need the database transaction to still be open. First and foremost, because like what happens if, let's say, the database transaction, or that write to the database, we write to the database, we write to the database, we send out that email successfully, and then someone pulls the plug and the transaction is gone, right? So it's rolling back or not it's not committing. Then we have sent out the email, but our system is still in the state before the actual checkout was triggered. Right? So that kind of stuff basically looking like this. It's notifications interacting with the SMTP server, and we immediately raise the question, okay, what if the interaction with the SMTP server takes long, or it's basically down and we run into a, I don't know, what is it, 5 to 10 seconds timeout, and still have to basically hold on to the database connection for all that time. And the other thing was, I think, what if the email sending succeeds and the transaction rolls back for whatever reason, right? That might just be an ordering issue, right? Even let's say the notifications listener is ordered before the inventory listener, and the inventory then throws some exception. It's kind of like all these questions come up. So the way this works is that time is going from left to right. So we invoke the original method and we create a business transaction, and the consistency scope is across the checkout module in the first place. We publish the event, and the event listener of the inventory is invoked. So the consistency scope now includes the inventory, and then we're good, right? So that's kind of the problem here, because that email notification might just it was a bit tiny in my graphic, but it might actually be much longer. So what if there was a way for us to basically decouple the interaction with the notifications from that entire interaction, so that we can kind of contain the transactional boundary, or make it smaller at least, right? So the way that we could do that is just watch this space here. The event listener is, we could make it a transactional event listener. That's a bit like one of the rare cases in Spring Framework where I think it's a rather unfortunate way of naming, because we and I don't really find a better name. So it's not an event listener that runs in a transaction, but it's an event listener that runs bound to a transaction, right? So the way this works is that this listener is triggered only on transaction commit. It's actually an attribute where you configure the transaction phase that you want to attach it to. But the way this works is that when the event is published, it's kind of kept in someone's bag until the transaction commit, and then the transactional event listener is invoked after that, right? This solves the problem of us sending out the email and then rolling the transaction back, because we would only attempt to send out the email if the transaction really commits, right? So it's like one problem solved, we're creating another one. Wait for it, as it usually is, right? A side effect of that is that, unfortunately, as the transactional event listeners are executed in the transaction cleanup phase of the original transaction, we still keep the connection open for the time being, right? So only after the transactional event listener has kind of concluded, we can close the original connection and return it back to the pool, right? So that's not really helping in that regard, but we've kind of solved the consistency problem in the successful case, right? Or we basically guarded the transactional event listener from running in the cases of a rollback. Still, transactional scope is across the checkout and the notifications, right? So we don't have them really decoupled. So what else can we do? One thing that we can do, and we actually suggest to do, is to run the transactional event listener in an asynchronous way. Fundamentally, this means that the invocation of the listener is kind of handed off into an executor service or any kind of executor infrastructure that you have configured or got configured through Spring Boot in your Spring application. And then this call here, this one, assuming this is the only event listener, this one would return immediately while this thing runs on a separate thread and then basically does its thing, right? This helps because the call immediately returns. We can actually, so that's why we have the async transactional event listener. We create a new consistency scope as a sibling one of the checkout one, and we can actually close the connection, the database connection much earlier, right? So that helps with that. Another problem solved, another problem created, right? Because what if that bloody thing fails, right? Remember, we've done our checkout, and let's say we stay with the inventory and the rewards program. That's still part of the smaller transaction, and then we get the notification triggered, or the notification listener triggered, and then we want to interact with the SMTP server, and it's gone, and it's running into a timeout and an exception on that other thread, right? So we've lost the notion of the fact that we still need to send out that bloody email. And there's a technology that's kind of currently built into Spring Modulith. It doesn't necessarily have to forever live there, but it's that's where it started and where it's currently usable in projects. So the idea is that when we publish the event in the first place, right, the order completed event, the framework knows about all the transactional event listeners that need to be invoked at some point, right? And because the event's publication happens within the original transaction, we can actually write additional database entries into the database that says, okay, here's my insert into order completed, what have you. So here's my primary state transition in database speak. And then we additionally insert into send out a notification for this event using that listener. And here's another listener, and we basically write a log of all the transactional event listeners that need to be invoked. Then the transaction commits, so we have captured that state inside the database, and then we immediately invoke the individual listeners, and for each listener that succeeds, that's kind of the entries in the database, and for each event listener that succeeds, we update, or we basically scratch out the line in the database. So with two of the four here failing, we would end up in a state where we have, let's say, we have completed the order, and let's say the first one is the inventory one, so we've done the inventory update. The second one failed. It was the, rewards program, right? The third one failed, was sending out the email notification, and the fourth one, I don't know what that was, right? But that's kind of the idea. And that's kind of, and then we provide you API to basically say, oh, please resubmit the events that have failed for that listener or what have you, right? So you could retry, quote unquote. It's not really a retry, but like at some point in time, you can decide to call code and say, please try to. We fixed the SMTP server. Now we can retry or resubmit the notification emails, right? In some cases, I think the SMTP server is a bit of a suboptimal example here. But in some cases, let's say we wanted to. Yeah, that thing is wrong here. Interact with SMTP server here is wrong. We've switched this thing to inventory back, right? So in this case, I want the inventory updating behavior be integrated in the same way as asynchronous, eventually consistent piece of code. What we need here is a new database transaction, actually, right? So we would end up with add async, add transactional event listener, which is quite a mouthful. It's correct because it kind of does what it says here, but because we think that this kind of eventually consistent integration of application modules is the default thing that you should apply to your Spring Modulith applications, there's a shortcut for that. It's called the add application module listener annotation. Right? So if you see this kind of annotation in your code base, and you know, okay, this thing is listening to an event of another module, and it's kind of running completely asynchronous with the the event publication registry applied. And I think I would like to show that to you in a demo. How much time do we have? 20 minutes. That's fine. But let's do the slide here. But again, the question: how does that change the way that we test our application? Right? And because now we have like thread pools involved and asynchronous invocations, and oh, what do I do now? Thread sleep and wait until the email has been sent? I don't know. So we decided to, similar to the assertable application events API, there's a new scenario API that allows you to kind of formulate how you would like to the module to react to stimuli that you basically put onto the module, right? That's why where the method stimulate comes from. So we let you think of the module as a box that you cannot look into, but you can only poke it. Maybe I should have called the method poke. But that's too associated to Facebook, is it? So we stimulate the module, and we can only use we usually use API elements of that module, right? In this case, it's a checkout test, so it's probably located in that very package. So we just call the checkout complete method. Alternatively, we could publish an event that we know the module will react to at some point. And then we can say, and wait for event of type inventory updated, matching value, and the inventory updated will get off some correlation through the order ID. So the thing that we piped in here would be reflected in there. And then we say to arrive, right? So in this case, this would be a test case that would, of course, need to include both the order and the inventory. And it would need the inventory to actually signal the outcome of the event in the form of the inventory updated event. Right, so it's kind of in this case, it's like a broader integration test of these two modules, but we ultimately test that the triggering of the checkout would eventually end up in an inventory updated code base. Right, so it's kind of Spring Modulith API. We still have the given when then thing. There's like other sorts of things that you can do here. You can basically not wait for other events. You can wait for a state change where you just pipe in a lambda and then can issue a database query that basically reacts to, I don't know, a status change or what have you. You can customize how long you would want to wait, how often it's supposed to be polled. There's a waitility library under the covers used. It's just a kind of nice way of basically writing down the testing scenarios here. Before we come to the slides that are not really slides, let's go back to the application and then not tasks, terminal, get YOLO. Steps 8. Yeah. We're living the future, right? Okay, then this is stuff that's already prepared for Thursday, but let me just briefly go here. The latest revision or something, I'm probably taking a bit ahead of, or a few things from the talk on Thursday. One of the new features in Spring Modulith 2.0 is a very revamped version of the event publication registry. The reasons and the consequences of that, I go into detail on Thursday, but you'll see quite a bit more output than if you've used Spring Modulith 1.x, the output will look slightly different than it did before when we discussed the log output here right now. So what I'm doing is basically there is this orders complete functionality, right? It publishes an event saying here an order completed. That's kind of it. There's a bit of Spring Data magic going on. But I have an event listener in here that is an application module listener, so an eventually consistent integrated event listener. One that I can actually configure to fail. Right? So if it's supposed to fail, it throws an exception. The sole idea of the exercise is I want to have an event listener that fails so that I can show you how the event publication registry keeps track of the thing that has failed, right? So, and if I run this, so I register the, how do I register the, here, I register the listener as a Spring Bean through an add import, then I call that method and I wait for the, event externalized. I haven't talked about that, unfortunately. But there's like actually two listeners for this thing here. One is an externalizing event listener that talks to a Kafka, basically taking the order completed event and broadcasting that to an external message broker. And I wait for that to happen. And then once that happened, I expect that I have an incomplete event publication exactly one, right? Oh boy, exactly one. And that's then going to be we're going to see in the logs that it's this one. And then I actually call the resubmission. So that's the code that you would likely would write if you like, okay, how do I now deal with the things that went wrong? And here's like a resubmission options in which you can basically define how many of these events you want to see or read in which batches and how many of them you want to resubmit in this case. So that's kind of the failed event publication. That's new API in Spring Modulith 2.0. How you deal with that. But I basically reconfigure the event listener to not fail anymore, and then basically we will see that the listener will execute properly, and then that we actually shut down with no event publications left, right? And bless you, by the way. First things first. So that's green now, and I think the most interesting part now is to really skim through the logs to see what's going on. Right, so what happens here is like we have an application module test, we bootstrap the order thing, and this is where this is going. You see Hibernate doing its job. It basically does some, of course, don't do this in any of your production projects. Let Hibernate create your SQL statements, not because Hibernate is like a bad thing or something, but you want to use a proper schema migration kind of thing, like Liquibase or Flyway, what have you. We're using the test containers integration. We bootstrap some Kafka here. And then what happens is the following. You will see there's probably a bit slightly weird ordering what you see here. It's this stuff. So we trigger the order complete method that changes the state of the order entity and then basically tells Hibernate to update the thing immediately. But because Hibernate is batching the interaction with the database to the very end of the transaction, you see that before that even happens, we see two inserts into the database, right? So we have the order completed event that is supposed to be why is the transaction synchronization? Okay, yeah. So there's like two. This is the first one. Order completed for the failing transactional event listener. That's the first insert. We need to invoke that. And the second one is the one that does the Kafka event publication message broker interaction thing, right? So that's the second insert here. And then finally along comes Hibernate and says, okay, oh, by the way, there's some actual state transition that we have to persist here, right? And what you then see is like you see two task threads going on here, right? Because as we remember, the event invocation is asynchronous. So there's a thread pool that now has two threads starting to process the failing event async transactional event listener, this one here, and the other one is processing the Kafka externalization. You see that the first one, task one, directly fails. It's just like a debug output here. That's the D. For the failing async transactional event listener. So here's the thing that we deliberately broke, right? And it's actually, if you skim up here, like its task, so it says the first thing it does before it even like invokes the listener, it sets the publication status to processing, right? So it deliberately marks the thing. Oh, I'm now working on this, and then task one. Already sets that to failed. That's basically the code that's then processing the exception, sets the thing to failed, and then gives you that's the asynchronous error handler thing that basically provides you with the exception trace here. That's going on. Task 2 is happily working in parallel by using a producer and talking to Kafka, opening a connection, yada, 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 yada. So that's basically done. And then it basically goes ahead and says, okay, the event externalized thing, basically the interaction with Kafka is completed, right? That causes a bit of update event publication set status to completed. And what you see now here is the invocation of the how many of these failed event publications do we actually have in the first place? That's this one here, where because it's asking for status status is not completed, right? Completion date is null. That's basically the failed status. And it's then saying, okay, it's already trying the resubmission. That's the second step. And there's another thread from the thread pool being pulled to then process the failing event transactional event listener that we have set to configure to not fail anymore. And then you see the update to first to processing and then first to completed. Even further than that, it does the resubmitted thing here. Resubmitting event publication. So that's kind of the thing. And then there's a final SQL query that says no publications outstanding. I can briefly, if we have that second, we have Command M. No, how do I minimize this? If I remove this here, and then we basically see the test shut down with some message that says there is a. So we basically. We wait for the thing to fail, we assert that we have one failed event publication, and then we're good. And what the event publication does on application shutdown is it finally gives you a kind of a check log of, oh, we're shutting down with these event publications unpublished, right? So this is this one here. And then you basically see that the failing transaction event listener is the thing that we would still need to do. And if this wasn't an in-memory database, then that thing would be present once we reboot Bootstrap our application, right? So that's the event publication registry, and the basically concluding the discussion of how do we actually let modules interact with each other? What ways are there? And then to really conclude that and basically scare you out is I have to show you this thing here, this monstrosity that's not meant to be presented at all, but I usually present it at every iteration I give them the talk. What's this thing supposed to do? For one, this is a table from the upcoming book on Spring Modulith. But what it's trying to do, and I think it actually does that quite well once you basically wrap your head around this. So it's kind of comparing the three approaches of module interaction. Right? Classic is via dependency injection, event listener is a standard event listener, and the application module listener is the most advanced, eventually consistent, yada yada thing, right? And the ultimate thing that you get here is that the module coupling is very high when you like call into another module. It's slightly lower when you just publish events that other modules react to, and it's the least possible if you integrate the modules in that eventually consistent way. And then the thing that you should notice is, and I probably have to find a way to make that a bit more visual, but if you move from the left column to the middle column, what changes is the way that the tests are written, but the consistency guarantees here, they stay the same, right? Potentially accidentally spanning multiple modules, the mechanism is a transaction, and it's the same here. And if you move from the event listener approach to the asynchronous transactional event listener, then this kind of stays the same. There's a bit of like change in the abstraction, but ultimately the testing approach stays the same, but the consistency approach changes. That's what the slide is supposed to convey. And because I usually get into the discussion, I've been to this talk of Ollie, and he said I should like integrate all my modules using application module listener, and that's exactly not what I'm saying. Right? Similar to the first half of the talk, where I said, here's this cool and fancy code generation thing going on for your JPA mappings, but please, if you have a team that's not comfortable with that kind of stuff, don't overwhelm them. Don't use technology for the technology's sake. Right? That's kind of the idea. So what I'm trying to convey here is that like if you feel like challenges or problems with the approach on the left, because that's how you most likely write applications these days, have a look at the middle column and see, okay, are there any operations, any interactions between the modules that you can replace with that, and then play with that, because you're changing the structure, but you're not changing anything to your consistency arrangement, right? It's a nice way to like make your first steps into that event-driven, asynchronously event-driven interaction of an application. And once you're familiar with that, maybe try the other thing as well, right? So it can actually help, because then you decouple these modules even more. In the other Spring Modulith talks I give, there's usually another step where I then go ahead and say, okay, now I've realized there's this one module that we actually need to turn into a separate application because of organizational reasons, or because we need to scale that even more. And when you've built the integration in the way that's in the outer right column, that's very easy, because you can actually exchange the module invocation. That's the reason why there was this Kafka integration in the last example. You can just take that out and add a Kafka listener, and then you basically get the same consistency characteristics in a separated system versus the one you have in the modular system, right? Also zooming out a bit, if you, instead of building a modular monolith, decided to build all of this stuff that I've just shown you, orders, inventory, what have you, as microservices, you have no option but the integration way on the right. It looks different, but that's what you're essentially doing, right? You kind of publish messages to another system that cannot be attached to any kind of original transaction or what have you. So if you build microservices, you're kind of forced to deal with that way, whereas in a modular monolith arrangement, you have the option of gradually moving to that place and getting your teams familiar with that kind of integration, because it definitely takes some time to get used to that. Right. So don't throw out the baby with the bathwater. That's what I'm trying to say here. It's all cool and exciting technology, but in the end, we not get bored for cool and exciting, but for, do we provide value or do we reduce cost? Right. That was the thing that I started with. All right. jMolecules is probably, I think you've got the gist, right? So we put stuff explicitly, the model design concepts in our code base. We can verify this stuff. It's very low-hanging fruit. It's also helpful for documentation, and whether we want to generate boilerplate code, that's kind of up to debate here. A lot of links in the resources, the jMolecules project, a couple of examples for jMolecules only. Definitely check out the books, Simon Brown, George Fairbanks. The paper from Emin Eden and Rick Husman is also interesting to read. It's actually a reasonably easy read, I think. Carola's book all the way. And with that, if you don't mind, leave me some feedback in the app, in the doc. Rate the talk. There's any kind of feedback. I've never learned from a man I agree with. It's something I always say, right? So if you have a contrary opinion, I'd love to hear about that, especially those, because that's what I and we all learn from. If I am lucky, I see a few of you on Thursday, at least in the spring team both, I guess. Right? Let's max out the room then. That's the tiny ones over there. So thank you for your attention. Enjoy today, tomorrow, Thursday, Friday, the rest of the conference. Thanks for your time.